Hey everybody, it's Marty the JavaScript Party. My buddy Rhett. We just got done doing a long video on voice. It's quite. It has become very clear to me how important, like, understanding the domain you're working in is, and how much more important it is than it probably has ever even been. At least in the United States, and especially in the enterprise. Um, I don't know, the only reason I say in the United States is because, I know that like different cultures come at things in different ways. So maybe, you know, the way a different culture works, they would obviously, there's no way anyone could ever be coding if they didn't understand the domain. I just don't know. Just belch. I'm trying to stop that. Um, but to be clear, I think and one of the things is maybe that is why I feel like what's happening in the United States right now is that software development in the domain in for the enterprise is just not working out. It just isn't. Like, bosses can ask you to build stuff. They can ask not you, but they like the vice president of some sales department, which I do know a vice president of a sales department very, very closely, um, can ask for software to be built. And they go to the IT side and they say, hey, can you guys build this software? And IT says, yeah, sure, it's going to cost $1 million. And then $2 million, and it's going to take us 3 months. And then $4 million later in a year, they get something that's not at all like what they were asking for. So, and then like the VPs are busy, they're super busy. So there's this agile thing which says like every couple of weeks we're going to go and we're going to do a demo for you and blah, 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 blah. But they don't understand exactly. And they don't want to. Like, sales is hard enough, or whatever they're doing is hard enough. They don't want to try to understand software development. And it's just not working out with the enterprise. Now, we still have two other sort of major um, things that need software. Rhett, come on. What are you doing? What's going on here? All right. So, we still have government work. We're still a very like big, massive economy with tons of resources and stuff like that. So we still have like the government work and all that. And so that's one thing. And I don't think we have as many domain issues in government work. I think generally the government has a better grasp on what they're actually what they actually need um, than um, than the enterprise. I think the enterprise is changing so fast all the time. We also have education work, right? We have like science and stuff like that that needs software. And then we also have like sort of Main Street work, that's businesses, stuff like that here in the U.S. So I think, but we are kind of, I think, sort of, it does not seem to be working out with the enterprise, so at least not at this time. But anyway, so I've been working on unit tests, which is something that is often demanded in the enterprise, which is a really interesting thing because I don't think generally the people that actually are paying for things and wanting things actually care about unit tests. But unfortunately, that the people that have all the credentials and all that generally want unit tests and all that. I have found that this product that I'm currently working on, which is supposed to be a 3JS visualization sort of tool, and the idea is kind of like a something in the browser where you can add a visualization like this and then you can manipulate it, and all that. Like, that's what I'm trying to build. I believe that this entire um, project has become just a sacrificial lamb to unit testing. Now, why? Why is unit test never dying? Well, because it's insanely useful for getting highly focused and truly understanding things. And so I have this one product. I have this one product. Let's see. I don't know, Brasstown Bald. Do you want that? Would you like that? Um, the unit tests are like get you so hyper focused on actual, like on the very, very most basic pieces of the code. And you can actually really use that to finely hone and tune your skills. I I have a couple more. I'm almost done with my voice visualization analyzer, and then as soon as that's done, I'm going to start two new projects. Well, I'm not going to do unit tests on that. I also have a lot of other side projects. I'm not doing unit tests on those because it just grinds it to a halt. But I don't regret doing unit tests. So I think unit tests are kind of like, I don't know. I don't know what a sort of a natural equivalent is, but it's kind of like wax on, wax off in come Karate Kid, where he's just like doing these things and like he the actual process of becoming a fighter is not happening, but he's getting better at the fighting skills. And it's like unit tests are kind of useless if you're not actually trying to do them on an actual serious project with actual complex problems. But if you ever have a serious project with, personal opinion, if you ever have a serious project with actual complex problems and become you become focused on unit tests, you probably just killed that project. The momentum of it's so hard. Every time you get rolling, you just get it. Just everything stops so that you can do the unit tests and all that. So, anyways, we have moved forward on our last. So right now we've got 496 out of 508 of our statements are covered. We have 61 out of 67 branches covered and 134 out of 135. We only have one function that is not. And basically what has been happening is branches has turned out to be the most challenging part. And what's starting to happen is that every branch is starting to become a function. And functions are just so much easier to unit test. And I think that things that are easy to unit test are things where it's easy to understand what the code is doing. And if you can understand if it's easy to understand what the code is doing, it's probably going to be a lot easier to maintain the code. So there's just sort of a lot of positive side effects that come from unit tests. But the one thing is, it is like, I don't know, like in sports or whatever, like you could be really, really good at the sport, but you're probably not going to get any real, you're never going to make a lot of money or get a lot of fame unless you do something like special that is like exciting in your doing of the sport. But if your focus is on being exciting during doing the sport, you're probably not going to, it's going to be harder to be good at the sport. So like a, so it's very convoluted just like that with unit tests. So anyways, every single file in this is 100% covered except for this visualization file. So if I come into the visualization file, we see that we have 122 statements and 35 out of 36 functions. So there's only one function in the entire application that is not covered, and that is in this file. So if we can get that function covered, we can have 100% on the functions. And then, but we have 6 uncovered branches, and my guess is we will have probably 5 new functions that we can cover, and they will replace the 17 branches. This is something that I sort of just started to kind of understand the last couple of days. All right, so now we click in here, and I have basically a couple things to work on, I think, and this is the most complex, I think, of them all. But I do think it is, I don't know, I'm not sure. But it kind of like, it's hard to understand what this thing is doing. And so when I was digging into this code, it's called is row available. So I think it is clear that it's just checking to see if a row is available. And by available, it's like, okay, so is the first row available right now? Yes, because there's only one visualization in it. Now is it available? Yes, because there's two visualization. Now is it available? Yes. Is it available? Yes. Is it available? No. Right? So now this row is full, so this row is not available. So anyways, so that is what that's what this overall thing is doing. But how is it doing it? Well, it's looping over all the visualizations and then doing a bunch of stuff. It's ignoring if it's not the same render. So like it's looking at all the visualizations, but it shouldn't look at itself. When it's calculating if a row is available, if it finds itself in the row, it shouldn't count itself to determine it, you know. And I don't know if that makes sense. I think it makes sense because basically when you create a visualization, it has to go somewhere. So the original place it's going to go is here. And so then it's going to determine, it's going to check everything else that's in there and see if there's a place in here for it to go. And it's like, no, there isn't. Okay, well now is there a place in here for it to go? Yes, there is. Okay, then I think the next step is that it'll try to find the place, right? So those are like kind of thought processes that you just never ever think through if you just get the code working. You just sort of get it working and you just move on with life. But anyway, so that's what this thing is doing. So we have this thing and none of our tests ever check to see if it's not rendered. So it would be pretty easy to add like something maybe in the current whatever is calling this, or maybe create a test that just tests this, and then make sure to send in multiple rows of, or current row viz current viz. So this is what got passed in, and then viz. And okay, so what it's doing is it's getting a, is this a component? No, this is a service. It's getting a service attribute called whatever this get visualizations returns. So it calls this and it creates a row of visualizations, and then it goes over it. So that alone is what I also discovered through unit testing, which is something that I apply to all my code now, is that interacting with the state and doing complex coding are easily separable and should be separated. And so they're not necessarily easily separable, because it would be hard, because see, this gets a row sibling, so we're doing this guy too, and then we're also doing this guy. So separating those out is a little bit harder than I was indicating. But it does seem, and I don't know exactly what, like the order of operations really matters when you're doing something like this. Sometimes things are easier if you start like at the lower levels and you kind of tease all this stuff out. Sometimes they're easier if you start at the higher levels. So like had I gone through this and found that we never ever, it's pure after this. So pure means it doesn't interact with the state and it always returns the same thing. With the given same input always returns the same output, and it doesn't interact with the state in any way. It doesn't read the state or write to the state. It would have been really nice if this didn't interact with the state at all, because then I could just get this list and then pass it to a function and let that function do its thing, and it would have been a lot easier to unit test. But I don't have that option because I'm interacting with the state or with the service through other things. So maybe it'll be easier to sort of try to break these things out. So it looks like here, all I care about is if this number is bigger than this number. And then I set a variable. So it would probably be a lot easier to switch this over to where I have a function that just returns true or false, and it takes two numbers, and and then returns true or false based on whatever those two numbers are, then I can test that function easily, and I no longer have a branch. What I have is a function to test. Again, these are kind of ideas that I've just never had even contemplated before. Just the whole concept of changing branches to functions so that they're easier to test. And I wonder if there's even a name for that. So, like, I doubt I'm the first person to ever think of that. So, I have found that functions are easier to test than branches. Dakota, stop. Okay. You're absolutely right. Functions are generally easier to test than branches. This insight is the foundation of both testing and software design. Why? Functions are easier to test than branches. Isolated behavior, simpler test cases, improved reusability, better coverage, metrics, error location. Examples. So related best practices, prefer pure functions when possible, limit side effects. I think pure function is not is the same thing as limited side effects. Use guard clauses instead of deeply nested branches. That is interesting. I don't even know what the word guard clause means. Follow single responsibility principle. So is there a single word or phrase that conveys this concept? I guess it's the concept of functions being easier to test than branches. There isn't a widely recognized that it can't place functions are easier to test than branches, but there are a few phrases, principles that imply functional decomposition. That's a good one. That's such a good one. Extract method, or it's a refactoring pattern. Separation of concerns. Pure functions are testable. Control flow obscures testability. Cyclomatic complexity. Yes, I see this word all the time. It freaks people out. Basically, every function will get a scoring system. And that scoring system, the lower the number, I think, the better. And a lot of places will not allow a function of higher than a certain cyclomatic score to do that. Functional over branching for testability. Function first testing. Branchless logic improves testability. Favor functions over flow. I like that. Favor functions over flow is pretty cool. So, sorry about the belch. I'm really working on stopping that. I don't know how I got myself into that habit, but yeah, these are this. So as a developer, I feel like I've grown a lot because this is just going to be in the back of my head all the time. It's like, oh, okay, should I just make this a function? Probably save me a lot of time in the future, just being like, okay, yeah, let's just go make a function. Anytime I start to think of, okay, I'm going to make a if then, okay, just create a function that just takes the two values and returns the value. So here we go. So we're going to start doing this functional decomposition. Functional decomposition. And we're going to take this guy and we're going to decompose this from a branch and make it into a function, which should be dirt easy, right? So this is line 258 in our service. So let's go to our service. Let's take this guy and let's just copy this. What is this? Compare right to, let's just do this. Compare right to width. So that's what this thing does. And basically it takes the right, which is a number, and it takes a width, which is a number, and it returns a Boolean. And I will say that there was a long time where this was highly frowned upon because we had like a limitation in code in which, um, like JavaScript, you would write the JavaScript and you'd literally send that JavaScript to the browser. And so, like, especially a lot of the big organizations that maybe have like a million, 100 million unique views a day, like sending this extra function was expensive. Um, but those days are behind us for so many reasons. One, at the very least, the easiest to understand is the fact that this is all going to get minified and it's also going to get optimized. And so this is probably going to be optimized away. The compare write to width concept, it's actually going to create it behind the scenes. It's going to do this. It's going to create. It's going to actually decompile this into what we had. So that whole concept is not a, a valid concept anymore. But a lot of people, a lot of old timers are stuck in that. So basically what we want to change this is to available is equal to this dot compare right to width, and then right to candidate, and then this viewport width. And then we're just going to take the code that's in here. We're going to copy it down there. And then we're going to tab that back. And then we're going to, one more. So I'm holding the shift button down in the tab to just get them all to tab to the left. And then we're going to go like this. And I guess I want to go one more. And we're going to say let available equals true. So basically we're just going to default it to true. And then we're going to test to see if it's false. And then we're going to return available. And we are going to change that from write candidate because it doesn't really care to write. And we're going to save that. So basically we change that from a branch, and basically we're going to get our available value back. And that is going to be a lot easier to unit test. We added a new function and we deleted a branch. And so that I want to see if that reality is true. So I think there'll be 16 branches, and well, no, we still have a branch because we have this branch in here, but we have a very easy to test branch, I guess. So we'll still stay at 17 branches, but we'll increase functions, and I don't know if it ever gets called. Yeah, so we don't get called. We maintain the same number of branches, but now we have two functions that aren't called. This one is so easy to, oh, well, okay, before we test it, since this should be easy to sort of make sure, before we write a unit test for it, it should be easy to actual test through the UI. So for me, since it's easy and I have a habit of testing things through the UI, instead of writing unit tests, I'm just going to go with that first. So it's working. It's definitely can recognize. I don't think this would work if, like, let's say we made this always true. I believe what would happen is that it would just keep on letting them go all the way out, I think. And if that is not the case, then we got, yeah, see, so basically now they're all on the same line. So we sort of tested it informally. We did an informal test of it, and we see that it is working right. So now writing a unit test for this should be just as simple as can be. And I will say that I have worked in plenty of places where I did something very similar to this, and whoever is in charge of me made me change it back to, or change it to where is that, and their argument is always, oh, it's just going to be faster. We definitely want performance, and it's just like it's going to be so hard to get someone. Like it's going to take. You're going to have to if to get someone there. You're never going to get them there on one spot to understand that. You're just going to have to like introduce the minification concept. Oh look. Oh, when I'm trying to do it's already minified. Blah 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 blah. Oh, oh look, they optimize it. Oh, so they've completely optimized that away in the code. And then, oh, I wonder, what do you think? Do you think this is optimized away? I mean, this is not a big deal because it's already optimized by the minimizer. And, that's kind of what it takes to get them there. Usually takes a couple of weeks. And then maybe you can start doing that. But then who knows? Whoever's above them may have a problem too. Anyways, checks right position against the width. And then we are going to pass that a function. So that is my assertion. I check the right person. And then basically I'm going to say const right is equal to 100. And then const width is equal to 50. And I believe it will go down that branch now. And this dot, no, it's service. Service dot, I think it's compute, create, check, compare right to width. And we know the very first one is the right, and the second one is the width. Turn it right and width. And I misspelled width. And that should get us our coverage that we want down here. So basically we want to see this all turn green, and we want this little branch to be checked because it only fails if right is bigger than width. It does not like this though. Is it supposed to be double quotes? No. Oh, I put if, not it. That is, my friends, this is what we call muscle memory. And then boom, and then boom. I think it's still testing probably. We should go over here to this so we can see when it's done. All the tests pass, and boom. Nope. So is right bigger? If right is greater, oh, okay, I screwed up. In the actual code, we want to not check against the viewport width, but we want to check against the width that we passed in. We want to purify this thing. And let's let her rip again. And there we go. Now, a lot of people would want to also check the other thing. Like I said yesterday, that's sort of another level I just don't want to get to. So let's scroll up here. So our branches are to 78.26. I felt like did we lose ground? I don't know. I felt we should have added one more. But anyways, I guess, and that's kind of one of the nice, oh no, because this is checking everything. But let's see, branches, we were doing 62 of 67 before. And it was 61 of 67. So we did increase our branch coverage. Now, I guess we need to try to take another step up. I think that was really good. And I do think that in the future, and the future is literally tomorrow, when I'm writing code, I will probably favor this pattern to this pattern. All right, so now basically right candidate. Right candidate is basically the width of the current viz and the end. So I guess it makes sense to create a function that just returns that. Takes two numbers, the end and the width. And viz width and uh, end is the last right. Um, the end plus the width, because that's would be what would fit in. So when I say what would fit in, I would say like here, add viz. So the next one will be for it to fit on this row, this spot has to be available based on the viewport width over here. So it's the end, which is here, plus the width. Um, so those fine details get lost, right? You get lost in that, and then when you're trying to figure out this code later, you get really super confused. So I guess we want to create a function that determines the end. I don't know if the end is a good name for it. Oh, it's the right candidate. Um, I do think right. I guess maybe right position, right. No, it's the position candidate, right? So position. This kind of indicates. I think this variable name sort of indicates uh, that it is a actual visualization. I think. I don't know for sure, but I think this should be renamed to position candidate. Probably right. Position candidate. And we are having a hard time getting to this line of code to test. So it probably makes sense. And there's nothing, it's not really doing anything where it needs access to that. So, I mean, maybe I guess I don't know. I don't know if I should pass in the width itself, so just as a number, just to simplify this, or if I should pass in the whole candidate, the whole viz. I think I should just pass in the width. Okay, so get right position candidate. And basically it's the end is the number. I think that's a start. That is the start position. Start position. And then this is the width. Viz width. And then its number. And then this returns a number. And literally all it returns is start position plus viz width. And literally we are just writing code just for, we're creating a whole function just so that it's easier to test. That's it. That is the only reason we're doing it. And I used to like it. I think I've mentioned before, I used to get genuinely offended by that. Like, why should I have to change the way I write my code just for a test? And I'll have to admit, I'm still not completely sold on the idea, but I do think that just as a side effect, it seems to be a lot easier to understand code. It just seems to be easier to come up to speed in code when you write it in this style. And this is I've sort of written in this style with all this branching and all that for 40-ish plus years. So it's taken a lot for something to convince me to completely change the way I do things. And that a lot thing happens to be my my unit tests. So, like, again, like it's hard. It's really hard to figure out So anyways, we know that we want that thing, we want it to actually compile. Um, so it did compile. Um, we want the existing unit tests to all still pass. So they all passed. This told us that they all passed. I think our numbers, I think our function number, our branches stayed the same, and our function numbers changed. So we have 137 functions now. We had 136 functions before. I don't think we test it, and our branches stayed at 67. 67. So what we have, oh, maybe it does somehow get tested. Um, anyways, let's just make sure this all works. And then reload this. And yeah, this is not tested. Now I will say that when you have a bunch of code like this, like, and you know, this is nothing, right? I've seen like functions that start like this, and there's literally like 400 lines in between where it starts and ends, and you tweak something in the middle there, and you don't have unit tests around it, making sure that it still works the way you think it, you know, every little kind of piece of it works the way you expected it to work is really challenging. Making sure that this works the way you expect it to work is not particularly challenging. That's kind of me just thinking out loud, sort of advocating for unit tests. Um, and there we go. And then it uh, gets the next candidate right position. And this takes two numbers as well. It takes a width and a right, basically. But this one will return a number. And again, like, we don't really understand everything that's happening right now because we are highly fixated on just this little piece working the way we want it to work. So const candidate right position equals, and then no, expect, not if. And that's, we want that to equal 1, 5. Ooh. And then it's still testing. And again, like, I'm learning stuff. I'm learning stuff, and then I'm changing the way I code. But there are a lot of people that still code the way I used to code before I learned this new stuff. And it's not enough just to be like, oh, okay, I understand how, like, I understand how things are supposed to work. It's also important for me to sort of think through, like, okay, how can I convince other people to change if they need to. All right, so now this thing is calling a bunch of functions, but it doesn't. So everything in here is calling a bunch of functions, but they're not. Um, but none of those functions really need any information from that. It, well, do I still? I thought I fixed this viewport with. Oh no, I didn't. I just fixed that in the test. So I think I don't know exactly how I want to try to make this work a little better. Because basically I want to be able to call all of this code. And I guess it doesn't have to be pure for me to be able to. Well, okay, I need this here to not be the viewport with. I think it's okay if it's calling functions. And this is new too. These are novel thoughts I'm having. I think it's okay to like call functions that are on that, but I don't think it's okay um, to depend on stuff. So I think what I want to do is right here I want to save a variable name and pass that in there. So again, this is all like it's taking me decades to decide to go from like I would say 20 years ago, the absolute knee jerk reaction that I absolutely am unwilling to change my coding style and all that for unit tests to being like, okay, yeah, I kind of need to do this for unit tests. Um, or I may need to do this. So it looks like this found row never gets used. Getting siblings for a row. It is important. I need to break this into its own function. So I think that comment is for all of this. I do not think this line of code does anything though. So I'm gonna, it probably ended up being over here by accident. So it doesn't look like I need this one. So let's just make sure that is in fact the case. Looks like it. Okay, so I don't even need that found in row, but I do want this viewport width. So I'm just gonna say const viewport width is equal to, and this actually gives me an opportunity to kind of talk about what I think is, there's three major things that I think you have to understand, or that if you understand them, it makes developing in software a lot easier. And there's sort of a thing that like if you think about it for a while, you'll kind of like, it'll kind of clarify something that makes it a little bit easier. So you might, if the comment, like it, let's say you're making a PR and a bunch of people were making a PR and they're all like, oh, this code here is problematic because let's see, like this viewport width might change between here and here. And so what happens if we're trying to compare, like let's say you're trying to add and you add and then the user moves it and this is and this was wrong, it would calculate it incorrectly because like the viewport width changed between line 251 and line 260. Like between those lines of code, it is technically possible for the viewport to have changed. And that is actually not true. Because like while the user could in fact move it, the page will not re-render between this line of code and that line of code. It absolutely will not. It will finish all this code before it redraws itself. So even if that was the case, like it would re-render, it would. And that there used to be a time that was like early in the code in browsers, it was possible that the page would redraw before the cycle was done. But when in those days, basically what would happen is like the application would just lock up because it's trying to redraw and then recalculate, redraw, recalculate. So now it goes all the way through every line of code in that, like if you look at the call stack of, and I don't know if we can, we'll have to like So there's like this call stack here. And what you'll see is like the whole, like when you're in debugger, you'll see all the functions that will be calling. It will finish the entire call stack. It will finish every one of them before it attempts to redraw the screen. It will not just redraw the screen mid cycle. If you can understand that, when you do understand that, uh, a lot of bugs that people have go away. But so there is that. Let me see. Okay, that's my wife. I'll call her right back right after this is done. She went to the chiropractor this morning, so she is probably just calling to let me know she's on the way home. But I will check on her in a second. Anyway, so that is that. So now we have this width, and we're using this viewport width. So that makes this a much purer function. And then, so then it seems like I could take this whole block of code, and I can say, or I guess I could take this whole block of code and turn it into a single function. Or I could take this whole block of code and pass in the row siblings and just check it. Or I can make another function that is the row siblings length and then pass that to a function. And const. No, I have to pass in all the row siblings because this uses that. I think it uses that. So basically, yeah, I could create a function that I pass the row siblings in that just literally does all of this. And then I can test that function directly. So I guess I will do that tomorrow because I really do need to check on my wife, make sure everything's okay. And this has probably gone long enough. 46 minutes. That's long enough, especially after that last video. We're getting close, though. So yeah, we got that one to do. We got to break this down more, and then there's a little bit more of a breakdown here, and then a little bit more breakdown here, and then it'll be, I think, very easy to, well, if this was a function, and yeah, if this was a function, then it would get called. It wouldn't, if it wasn't a branch, if it was just like literally all I do is pass it the current viz and the viz, then, but the thing is it does something. It does this available. It's okay. So it sets this available. So yeah, it'd be nice if this from here to here was a function that just returns available. I think that's the game plan, is to take this function and have it return available. So, and then this thing would be a hell of a lot easier to understand. I think get right position for candidate compared to right. All those things are a lot easier to understand. I think the totality of is row available, and then whatever this thing would be like, examine visualizations for availability or something like that, and it returns a true or false. I think it's pretty easy. It's kind of like this guy, maybe this guy, current row. So see, he gets everything passed in. Like it seems like there's maybe a pattern here, like where we want to collect up all the pieces of information. Maybe all it needs is the visualizations though. Right? So if I have a list of visualizations and I pass it to another function, is there anything that it needs from? So it needs this viewport width, which we can easily calculate up here and pass in. And that's, I think, it. I think all the rest of it's just functions that it's using. So yeah, it kind of seems like that's, let me do that really quick. Let's move this guy, and actually that'll get us a line of code. And not only that, but like for the people that are like concerned about performance, we're only checking this once now. We're not checking this for every visualization. So that is actually an absolute win. Um, so I think this line of code will get taken care of now. Let's just let this build, and then I've got to go. Yep. So now that is another line of code that got covered. Um, I don't think it helped with our problem is in the branches, not in the lines of code. But yeah, so now we only have 10 statements that are uncovered, and we still have 5 branches, and we only have one function that's uncovered. So, anyways, I don't know. I've definitely not come into any absolute conclusions at this point, but I am really strongly like, I'm loving the fact that I've done unit tests, and I'm definitely altered my views and altered my coding style as a result of this, what I'm doing right now. But it is fresh ground for me. So like, I don't know what the possible negative implications of sort of the direction change that I've sort of embarked on. I do think it's a really good direction change, though. I think this code is a lot easier to understand. Anyways, happy coding, everybody. Bye.